Okay, all
Okay,
right.
got it on the laptop.
All right. Looks like you can see it. Do you see a guitar body part?
Yes.
Okay.
All right, so I see a guitar body, yep.
Okay, great. Okay, so we can get started. So what I have here is Rhino and Rhino Cam. And if you've already got the demo, have you had a chance to play with it at all?
Very slightly.
Okay. All right, then I'll go through some of the basics first, so just to give you a jump start on it. So once Rhino Cam loads, you'll see a menu bar entry up here for Rhino Cam 2021 if you got the demo. And then we have multiple modules, mill turn, profile nesting, G-code editor, and then we also have a mesh module. Those are all different modules that you can, they're independently priced, and you have to, those are modules that you can add on if you're interested. And then we also have a nesting module, and then we have an art for, creating 3D models out of reliefs and bitmaps and things like that. And then some of the utility functions here. So as let's say, if I do that, if I select mill, I'm going to see a mill browser. This is what we call the machining browser on the left-hand side. And that'll come up. And this is where you're going to do all of your programming from. And so here, this little button tells you which module you're running right now. So right now we're in the mill module. And the product is set up to, so it has two ribbon bars, if you will. These are called ribbon bars. So we have the program ribbon bar and all the functions. You basically work your way from the left to the right, and you go walk your way down each column, and then you work your way left to right. That's basically the way it's designed. So it's kind of intuitive that way. The first thing you would do is define your machine tool, select your post processor, and then do any setups. You have a 4-axis, so you might be doing multiple setups. So you might want to come in and machine the part from different orientation. So this allows you to do that. And then you define your stock model for your actual workpiece for simulation, and then some stock model alignment functions here. And then you can also define material, what material you want to machine. And then this is where you're going to do the bulk of your programming. We got a work zero. You can set up work zeros. We have 2-axis machining. So this is basically all the methods using curve-based machining, facing, pocketing, profiling, V-carve, engraving, and then we also have slotting, chamfering, filleting. I'm showing you our full product, which is our premium configuration, which is basically the entire set of functions that you'll get if you get the premium configuration. But this 2.5-axis, most of you will get it if you get the pro product. Hole profiling, hole pocketing, thread milling. We also have T-slotting. And then we have knife cutting, a tangential knife, as well as rotary knives we can use. And then remachining. So this is where you can come in with a smaller tool and machine areas where a bigger tool couldn't get in. So far, so good?
Okay.
Okay,
Yep.
and then this is our 3-axis module. This is our advanced module that I'm showing you with all the different 3D methods. We have a new adapter roughing module we just introduced in 2021, which is basically a high-speed module. If you're machining, pretty hard material and you want to run your machine at high speeds, always have tangential cuts. This is what you would use. And then you have Z-level roughing or horizontal roughing. If you ever wanted to do plunge roughing, you can do that as well. And then we have re-roughing, quite a lot of functions here: clear flats, parallel finishing, horizontal finishing. As you can see, quite a whole lot. But what I'll do is I'll show you some of the most commonly used functions that people run through in their programming when we get into actually showing them. And then 4-axis, this is what you were interested in. 4-axis methods, we have rotary instancing, so you can take a toolpath and instance in multiple orientations about your 4th axis, and then create round. If you had a rectangular block of stock, you can actually create a round stock out of it, just a convenience function. And then we also have, as far as 4-axis is concerned, there are 3 types of machining. You can consider them as 3 classes of machining. This is facing, pocketing, and profiling, R-level roughing, and an R-level finishing. They're basically wrap methods. Are you familiar with wrapping, the terminology?
No.
Okay, so basically what wrapping is you have 3 dimensions, right? X, Y, and Z in 3 axes. So the wrapping, what we do is we take one of the dimension, maybe either the Y or the X, and convert that to an angular dimension. So you're still, you basically are wrapping a 2D toolpath onto a cylinder, if you will. So, and
I
there are,
understand. Okay.
yeah, so there are many functions, many types of parts that you can machine with the wrap function, and I'll show you a few of those. And then we
Okay.
have parallel finishing, and these are more advanced methods. These are called projection machining. So you're actually projecting it onto the 3D model. And then finally, we have the drive surface machining, which is basically our advanced premium technology, which is using surface models to create the drive path. So I'll get into that a little bit. So quickly, so that's basically the layout. And then we also have the simulation tab where you can simulate the toolpath. This is the workpiece, and I'll run through this very quickly. Okay, let's say you brought in a part like this and you want to machine it. The first thing you want to do is define your machine tool. So this is a machine tool definition. So we will talk about the manual definition. So we can define machines either as a 3-axis machine, a 4, or a 5-axis. So in this particular part, I'm just going to use a 3-axis machine. So I'll define that. You can set up the limits. All of these are grayed out because we just chose a 3-axis machine. And I'll hit OK. Next thing we do is select a post processor, and we ship with over 350 posts. So I don't know what controller is your machine using.
Yeah, we're Mach 3 and Mach 4.
Okay, all right. We have you have a lot of customers using Mach 3 and Mach 4, so it's already built in. So we have Mach 3 ATC, which if you have an automatic tool changer, that's what you would use. And I'm thinking you're using imperial or inches, right?
Yeah, we'll no, we use the answer. I'm not sure I understood your question.
No, you're using inches rather than millimeters. You're in the U.S., so you're probably using inches.
Yeah.
Oh, okay.
Yeah, we actually do both, but you can just do it in inches.
Okay. All right. I'll select the Mach 3. And then there are some additional controls for you to help you in the post-processing. What's the type of file name that you want when you post-process? What is the order and things like that? And then the extension of the file. All of that you can set up here.
Right.
So when you buy the product, we guarantee that we'll supply you with one post that works on your machine. Any additional post, let's say you buy a machine and maybe 6 months or a year down the road, and if you want a special post worked out for you, if it is part of the list, you can get it. If we have to do some additional work, there'll be an extra cost item.
Okay.
Okay.
Well,
so,
I know that we would actually want. We would want 2 separate posts for the 2 different machines.
okay, so you have the Mach 3, which is already built in, so there's no problem with that. And what's the other machine that you have?
Yeah, it's Mach 4 on the 4-axis.
Okay, no problem. We have that too. So you
Okay.
get it as part of the library. So there's no special, some people have some special controllers that we don't have in the library. In that case, we'll have to actually program it. And that is obviously time and material for us. So there'll be an extra cost.
Okay, I understand.
Okay. All right, so let's start with, I'm just going to show you some of this methods. I can just run it. Let me do that. So horizontal roughing is what I'm going to do first. This is a 3D part, so I'm just going to take this entire part and say I'm going to do a horizontal roughing. I'm just going to basically mimic what I have here. So let me get rid of that. I'll get rid of the toolpaths. Okay, so I'll just show you quickly. Let's go into 3-axis. Very simply, I'll just take horizontal roughing, which is probably our most commonly used method for roughing. So this is basically, some people call that Z-level roughing. I'll just remove that. So you can contain the cutter using curves if you want, but let me show you without any containment. So I'm just going to use as a flat end mill. This is a tool library that I've already loaded. Oh, this is a millimeter. Okay, this is a millimeter file. Okay, that's fine. So I'm just going to use a 12.7 millimeter flat end mill. As far as the different types of tools, I'll show you the different types of tools that we can create. Oh, okay, there you go. So as far as this toolpath method is concerned, you have the ball end mill and a flat end. You have a corner radius, you have V-bits, and then you have a taper mill, taper end mill, or taper with a corner radius, and then you can also use a shell mill. Those are the different types. So, okay, I'm just going to feeds and speeds. We can set up different feeds. There's a lot of control for you to select the feeds and speeds. Cut feed, plunge feed, approach feed. There's quite a bit of control here. And then I'll select the clearance geometry. As you can see, it's a clearance plane just above that surface that I'm going to use. Cut parameters. Let's go to the cut parameters here. I'm sorry. Okay, cut parameters. You set up the tolerances, any thickness you want to leave. Since it's a roughing method, I'm going to leave about 0.6. Maybe this is a millimeter model, so I'll leave 1 millimeter. And then there are different methods, types of methods you can use for machining. You can do as offset spiral, quite a few of these. Linear cut patterns, spiral
Let
cut
me ask you
patterns.
something real quick, Art. Are you saying that you're offsetting your roughing a negative 0.6?
Negative 0.6. Where do you get that 0.6 from?
It might have been my transcription. But you're doing your roughing with a 0.6 offset. Is that correct?
No, I'm saying I'm leaving 1 millimeter thickness of stock, so I'm not getting any closer than 1 millimeter to the part. So that's the thickness I'm leaving.
Okay, I follow you.
Yeah. Okay, let me just generate now. So as you can see, it's a pretty complex model here. Is looking at the workpiece and is coming up with the toolpath. So I can display the toolpath on multiple levels. So that's my first Z level. Second, as you can see, it's pretty quick. And then it's going into these pockets there and machining that.
Yeah.
And since this was an open pocket, it actually connected over here, this pocket here. This was an open pocket, so it actually connected to it. So, I mean, one of the things you would probably not want to do is you want to clear out all this material over here, right? I mean, that's silly to be running your cutter and clearing the material out there. So what I would do is I would create a containment boundary. So I'm saying, you know, I can come in with a profile pass around at the outside. So I just want to machine the inside portions. So I can select a containment boundary here, and I created this one already. And I can say generate. So now the cutter is going to be restricted to be within that boundary.
Yep.
And then again, I can display it in levels. So there's doing the pocket, is doing the outside. Okay, let's run the simulation now. So right mouse click and say simulate. If you don't want to watch it, you can always stop and run it to the end, pause and run it to end.
Okay.
So that's my actual roughing toolpath. Because of the boundary, it didn't get a lot on the outside, which is precisely what I wanted actually. Then I can run a outside toolpath. I can actually do a 2D profiling toolpath. Pick that and select that. Go outside. So let me do that. I'll do a profiling. Drive region. I've selected that drive. Select my tool. I'll probably select that the big tool. Cut parameters. Cut levels. I'll run it at one level. It's okay. I'll say it's at the top, and I'll say the depth of cut that I want is to go from here to here. So that's 32 millimeters. So maybe I can do 2 cuts or 3 cuts.
And
Okay.
I assume that I can go in and assign those manually throughout the depth of cuts.
Right. Yeah. Yeah. You can set up roughing cuts if you want. You can segment the cuts into roughing and then finishing, and there's quite a bit of control for you. So you can do maybe 75% of the top section as roughing with the different cut distribution and Z distribution rather. Let's say 10 millimeters for the top 25 millimeters, and then the bottom 5 millimeters you want to do 1 millimeter cuts. You can set it up that way as well.
Gotcha. Okay.
Okay. So and I'm going to do use outside, and I'm going to outside cut. So there, we created that toolpath there. I can run that simulation now. I'll clear the outside for you. Okay, and then last but not least, I'll just do a surface finish on the top and probably avoid these regions in the middle, so I don't want the cutter to come in. I'll turn off the gumball. So let me go to 3-axis advanced, do my parallel finishing operation. Okay, I got this outside region to cut. So I'm going to contain my cutter to be on the outside. I can also say, add these as the avoid regions.
Okay.
I don't have an edge there, so I got to select that. Sorry about that. I should have created this. Yeah, you can use some of the Rhino commands to create a curves. So let me run it. Open loops found. See, this is what I was saying. Okay. Yeah, the curve was not close, so let me recreate them. Let me take out all of these.
Then I just have a closed vector operation.
Yeah. So let me use the Rhino tool. That's where the power of the Rhino comes in. So you can go to curve from objects. You can extract duplicate border, and you can just select that. Oh, that's not the surface I want. Maybe that one. Yeah. I can duplicate that border, and it created one border curve for me there, right there. So that's a close curve. But I shouldn't. Anyway, just for our purposes, I'll show you. So I'm going to select curve edge. So I'm going to do that. And then also, okay, That didn't create an open, that also created an open curve. So let me run it. Okay, it just created the toolpath, but as you can see, it went in. And to avoid it, I need to create that curve out there and say avoid that curve. So I don't want to waste your time creating that. So, and obviously I don't want to use a ball mill. I don't want to use a flat mill. So, and another thing is to put it on the top so I can just drag and drop it at the bottom because I want to do the roughing first on the outside and then do the parallel finishing. And I don't want to do a flat end mill like I did. So I'll go to a ball end, maybe and then generate. So there you go. So any of these curves that you want to avoid, you can select them as avoid regions.
Okay.
Okay, so that's pretty much a quick and dirty demo of what you have. See, there's probably the most often used methods, the roughing methods and the parallel finishing methods. And then we have I can show you some examples of the kinds of parts that we have or we run into. Okay, let me see. So we talk guitar parts. Maybe we do have some mold. That's a flower mold. Maybe that's a little. This is an aluminum mold. I can very quickly generate a toolpath. So this is also in millimeters. Parallel finishing, again, that's our most commonly used method. Okay, let me pick a ball, generate. Okay, that was quick. There's your toolpath. Create your stock. I can do a box stock, different types of stock models that I can create. Pause to end. Ooh, screen sharing is paused, it says. Can you see my screen now? Okay, there you go.
Yes.
That's the simulation. So, okay, so those are some of the different kinds of parts, mold parts. If you have some kind of rosette or any type of architectural parts that you machine, we have a lot of people doing a lot of those architectural parts. Let me bring that in. I'm trying to get something this is very complex, so this give you an idea of the types of parts that we can machine. Okay. Oh, that's a terrain model. Somebody's using our product to do a terrain model. There's a parallel finishing that did with a flat end mill. Can you see that?
Yes.
Looks like you're, that thing frozen. It's like.
No, we're in real time. I think we're okay.
Okay, there you go. Yeah.
You're running a roughing path on the topical.
Yeah. Okay. And this is the complex finishing pass that they've done on the terrain model. It's pretty complicated stuff. And then they've done a horizontal finishing. Yeah. So
I'm
we
just
can.
curious what makes that such a complicated piece.
Well, it's just large. The piece is pretty large. and it's got a lot of different features. You know, as you can see, quite a lot of features. So it's not a simple surface that we saw like in the mold part. This can take a lot of RAM, a lot of resources. So,
Gotcha.
okay. Anything else you'd like to see in the 3-axis before I jump into the 4-axis?
No, I think I think Nat, do you have anything you want to say on the? Yeah, I think I'm pretty clear on the 3-axis stuff. I mean, for the most part, it's just going to be getting used to where your features are, and I'm sure you guys are going to have some that are verb different, and just have to become acquainted with the actual program
Yeah,
itself.
yeah. And the terminology is probably slightly different, but basically it's if you know one CAM system, you can transition pretty easily. So,
Yeah.
okay, let's
Okay.
jump into the 4-axis.
Yeah, let's do that.
Okay.
Oh, wait.
Okay.
In the beginning of this, you said that there was something in the Pro model creating tool paths from bitmaps.
Yeah.
I want to see that.
Okay. All right. I want to let me. Let's see. It's nothing like an
And if you're
unscripted
gonna if
demo.
you're gonna start if you're gonna start letting me take pictures and then you're gonna create the tool path off of my bitmap, I'm gonna give you a big hug and a kiss.
Okay. All right. I'm not sure if I would appreciate that, but okay.
Fair enough.
Okay. I need to get some pictures loaded. Let's see. Let's see what I can do here. So for that, I need to load the art module. I go in here and I do turn in the art. Okay, this comes in at the art. Let me create a new model. Let's say small objects. Let's go inches. Is that your son?
Yeah, that's my son.
Yeah, you can get a picture of him and. Okay, so basically here what you do is you create a project. So you can define it as a project. I say 5x5. So that's basically my project width.
Okay.
So like that creates that. And then what you can do is you can, let's say raster to vector. We can convert raster to vector or do a relief.
Yeah.
So we have the bitmap files, JPEG or GIF. So I need to get something. Well, let's go to test parts. Hang on one second.
Okay. Ooh. You gonna show us how to do this programming? You're gonna teach us?
Okay, hang on. Any toolpaths, any pictures here?
So while you're looking at that, I'm going to give you a real life scenario that I'm hoping this might be able to help with. So, for example, we've got an area that has some late 1800 corbels.
Okay.
And they want to recreate those corbels.
Okay.
And typically, when I go about doing something like that, that entails hours of me drawing this corbel. So what I'm hoping is you might have found a solution to ease that process to where we can recreate an existing image
Mm-hmm.
off of. Am I along the right track with what
Yes.
you're doing there?
Yeah, you could do that. You could take a picture of the corbel and then bring it in. Texture. I don't have anything here. So materials customized. Machines. Give me 1 second. Okay, that's all I have. Okay, man, I can bring that texture in. Let's do that. So let's say a picture like that. And it's a grayscale. So, and I can specify different colors. If it's a color bitmap, I can change the colors. It's filter out certain colors that I want or don't want.
Yep.
So there.
It's like a typical bitmap conversion.
Yeah, that's all it is. Yeah. So it converted that texture.
Yep.
And then once you can do that, you can mix and match. You can convert that into a mesh. So this is right now what you're seeing is just a display. It's our internal display. So we can export that to a mesh, to CAD.
Okay. And then you would edit it in your CAD program
Right.
and then import it back in.
Right. Yeah.
Okay.
Generate. So there. It's actually generating. It imprinted that on my model that I had. So I can now export that. So there's my, actually I created two meshes. Okay. So I can go back now into mill. So that's a mesh that mill understands now. And this is an inch model, 5 by 5. So let me see, 1/4 inch. Just select that tool. I can run a very quick toolpath on it. Parallel finishing. Run it. There, finished. I created the toolpath. It's a large tool, so it's probably going to defeature some. So I'm going to make a smaller tool, select a smaller tool. I'll probably run it even. Okay, and then I don't obviously want a machine on the outside, so I can create a boundary. So I'll just create a containment boundary here.
Yeah.
And then select that containment boundary. I don't know where I got that one from. Okay, let me select that curve. Okay, let's say generate. Okay, there you go. I just created inside that. And then if I create a stock model, go to simulate, and then simulate play.
Let me ask you a question of ignorance.
Uh-huh.
What is the actual point of you having a stock model? Do you predefine tool like rotation speeds and feed rates into the actual substrate,
No,
or I mean,
no. The stock model is basically what your workpiece, your raw stock that you're going to be loading on your machine. So
yeah. So I mean, am I defining that just for modeling purposes, or I mean? What's it really
For the
matter what?
simulation, right? You want to see how that the material is being simulated. So
Okay.
that's
Yep.
let's say that's
So
your part that you're machining. That's a block of wood, for instance. Let's say it's sitting on the table, and you've generated the toolpath. So you want to see how it's going to actually machine out. So that's what the stock model is. It's purely for the simulation purposes.
got you.
And then,
Okay. Yeah,
and,
that answers my question. Thank you.
and then also we use that stock model for what we call that in-process stock. So once you run the simulation, you can do a re-roughing using that stock model. So we know where there's material to be machined and where there's empty air, right? So we can be pretty smart about where to machine and where not to machine. So that's another use of the stock model. So there.
Okay.
That's that texture file that I brought in and created a mesh and created a toolpath out of it. So you can do
Yeah,
this
that's
with
cool.
with pictures and any bitmaps that you have with that art file.
Okay.
So you're looking for Corbel files. We have a lot of customers using, having Corbel type of things. I'll show you a part. This is actually a pretty good part. Something like that. So this would get into mesh. If you have a mesh geometry, so this is what we call, I don't know what you call it in your industry. This was actually scanned in. This is again very similar to what you're describing. It's some reverse engineered in.
Right.
As you can see, it's all the meshes there. And then we've done a roughing on one side, on the top, and we've done a roughing
Mm-hmm.
on the bottom. So this will work perfectly with your 4-axis machine. And I think this customer is actually using a 4-axis. That's why he's got a block here sitting here. So you can anchor it to a 4-axis head, and then you can rotate the machine the top, then flip it over and machine the bottom, and then do a finishing on that, and then come back again and do the finishing on top.
Okay. Gotcha.
Yeah, and then
That's
you
a
can
good looking
also,
piece.
and you can rotate it 90 degrees and machine from this side as well. So this is a perfect example. It's probably something what you're looking for, correct?
Yep.
Okay. All right, let me jump into the 4-axis now. So our 4-axis module is very similar in terms of usage to the 3-axis that I just showed you. So if you're familiar with the 3-axis, 4-axis should be very similar. So I'll bring this file, a simple file, just to show you some of the capabilities. So let's say you have a part like this and you want to do some drilling. Let's say you have, instead of having a round stock, let's say you have a stock like this. This is what you have in your shop. So I mean, not necessarily a round stock. So we have something called a create round method. So that once you create that round, so we create a toolpath that basically will allow you to create a round stock out of a rectangular block. So that's what we're doing here. So let me run, that's that toolpath. Let me regenerate it very quickly. So it's already done. And then I did okay, let me run the simulation. That makes more sense. So run that. So it's taking that rectangular block of stock and machining a round out of it. Obviously, this comes in useful. And there's really not much interaction. There's very pretty automatic. It knows where the part model is and it knows where your stock is. So it machines to the bottom and it leaves a thickness. This is the amount of thickness I specified. And then I did this is what I call the wrap method. I selected these two curves and I did a pocketing method. So basically, internally, we unwrap that into a rectangle and do a pocketing. And so now I'm actually finishing that. If I need to finish, I'm finishing it with the rectangular block. I mean, a rectangular tool rather, flatten tool.
Hmm.
Okay, so obviously we are showing the tool being rotated, but on your machine, your table is probably rotating to do that. So that is an example of a continuous toolpath. And then for this chamfer, this is actually pretty interesting. There's a little chamfer there. And since on your machine,
Yep.
if you don't have a 5-axis machine, if you had a 5-axis machine, that's great. You can come in with a flat end mill and go normal to that surface. But since you don't, most people don't have a 5-axis machine, we can resort to a 4-axis toolpath. Again, I created what's known as a 4-axis projection pocketing method. I picked these two curves, and I generated the toolpath between that. It's actually generating right now. Okay, it's finished, and I can run the simulation on that. So I created that with the chamfer with the ball mill. Unfortunately, there's no other easy way to cut that 5-axis chamfer.
Let's throw a V-carve bit in there and do it in.
Yeah, we could do that. Yeah, take many passes. Okay, so let's say I want to let me just remove this. I want to drill those holes. I have those holes. So we have a 4-axis hole making methods as well. So I'll select. Oops. Let me go. Select drill points. I'm just gonna go select all the points here. Ooh, that's not what I want. So if I turn on the filters, selection filters, which I had on here for a minute. Okay, I'm gonna turn off the poly surfaces, curves, and surfaces. My selection. Sorry. Okay, 4-axis drill. Grabs. Oh, still selecting it. So you're selecting. Oh, I got the curve selected too.
I'm assuming your drilling path has pecking and retract above
Yes.
certain
Yeah.
height, etc.
Yeah. We have all of those. So there's your drill toolpath in 4-axis mode. And yeah, we can define cycles, pecking cycles, and also even user-defined cycles. So
Yep.
that's not the tool I wanted. So I can go in and change the tool. I'm using a ball and mill. I could use a drill. I think it's a 1/4-inch drill. And I can set up some sorting methods for drilling. If I wanted to do minimum distance, there's control for it. I can do minimum or directional sort, and then go low to high, maybe zigzag rather than one direction. So there's a zigzag pattern. It's going in one direction, coming back. Let's run the simulation. That's better. Okay, there you go. So that gives you a quick overview of our drilling methods, drilling and 2.5-axis, or rather wrap methods. I'll show you different class of parts we can machine with our wrap. Let me just bring that file over. Okay, here you go. So if you have a part like this, we can do what's called a 4-axis facing. I've selected these curves and done a 4-axis facing. So basically my cutter is an open pocket. My cutter is coming from the outside, cleaning it up and doing multiple passes all around this. And then I can do a finish pass by selecting those curves. And then again, running a 4-axis profiling toolpath, which is very similar to the 2.5 axis, but it's doing it in 4-axis mode. Now, if I want to machine these pockets, there's an interesting way of machining this. So I create one toolpath for this pocket by selecting these boundaries and using a 4-axis boundary. So let me do that. Actually, I'll show it to you how that's done. I go to 4-axis, pocketing. Okay, I'll remove all. And then I'm going to select surface boundary as my pocket. So I just select that surface, that's my pocket. And a tool, I can use a flat end mill. I'm using a flat end mill. Cut parameters, offset cut pattern. I can use a linear or offset. Let me do an offset. So I get this.
So on your 4-axis pocket, that is actually pocketing the bottom profile of that at the same radius as the surface.
Right.
So
exactly.
you're not getting a flat pocket at the bottom. You're getting a radial.
Yeah, you can see that radial, right? Can you see that?
Yeah. I just wanted to confirm that.
Yeah. So now, since I have one pocket, I know it's pretty symmetric. I have about 4 of these, instantiated around that cylinder. So I have this cool method called rotary instancing. I can say, give me 4, total number of table rotations, 4, 90 degrees. So I create that. And then I just grab this 4-axis pocketing and move it under the rotary instancing. So basically I get 4 now. And the posting will work correctly once you have the rotary instancing. It knows, the post processor will know that it has to index by 90 degrees and it'll do the indexing properly.
Gotcha.
So
let me ask you this. So if I had a cylinder like that and I actually needed a true bottom pocket that was not the curve, would I just have to draw that in the part? Or is there a tool path that will automatically do that?
You mean the surface is not on the cylinder? Is that what you mean?
Yeah, so at the bottom of the pocket, if I wanted that to not have a radius on it, is that just something I would have to draw in the actual part?
Yeah, you'll have to model it that way. You'll have to have a straight cut. And that's where the Rhino, power of Rhino comes in. You can model it pretty nicely, easily there. So that's really the combination of Rhino's power and RhinoCam is where you get this, a lot of efficiencies here. So the nice thing about doing things like that when you model it is pretty intuitive. So you're not playing games. It's what you see is what you get. So that's the way we have designed our system. So okay, so we can run the simulation on this. Let me delete that out. So I can do a simulate all. Where is simulate all? I can simulate to end or play. There you go. Sorry, that's a big tool holder. Yeah, I turned off the tool holder. So let me run it again.
And so I would imagine we could set the simulations up to where the 4-axis actually turns the table, not the spindle.
Yes, yeah, that's a whole new ball game. So if you want to do it that way, we can set up your machine tool. I can show you very quickly. Hey, hang on one second. I'll get to that at the end. Remind me and I'll show you the machine tool simulation. Okay, so these are wrap methods. Some of the more complicated methods, the projection methods, I'll show you. So you can see a lot of power here. Yeah, this one was the file that I'm going to show you. It's a part to be actually machined. It's a customer part. It's a bottle like this. So the way you would machine something like this is you would set it up on your machine and come at it in one orientation from the top and do a horizontal roughing. So you rigidly locked your part and machined, and then flip it over and 180 degrees and machine it from the bottom. And then finally you can do a 4-axis finishing toolpath. Let me run this simulation very quickly to give you an idea. Okay, there you go. That's the toolpath from the top. So you did a roughing, and then we did that to the bottom. So there's your model roughed out. And then next you can run the parallel finishing toolpath. So
Okay.
okay, so that to end. So, and you can go along or across, and then also do helical patterns. If you want to do a helix, you can do helical patterns as well. Okay, there you go. That's a pretty nice finish for you.
Yep.
Okay, all right, let's see what else. Okay, we're finally at the part. More complex, a little bit more complex than this type of machining is what we call projection pocketing.
Okay. Tell me more about
Yeah, so I'm trying to get a part here. Hang on, give me 1 second.
that. Yep. Now I see it.
Okay, so this is pretty, what we call drive surface machining. So I've done a horizontal roughing, and then I've selected a drive surface. This is using our advanced 5-axis. This is true 4-axis machining. When I say true 4-axis, you're actually moving the X, Y, Z, as well as one angle. So all 3 linear axes and plus your rotary axes can be moved with this. So here I've selected the bottom surface. There's this bottom surface here. As you can see, can you see that green outline? That's my control geometry that I've selected. So that's my first surface, second, third surface. So I selected that. That gives me my cut pattern. I'm using that to create a cut pattern. And then I'm selecting the rest of this is actually a mesh. I think that's a mesh. No, it's a poly surface. Okay, it's a Rhino poly surface. So I'm using that as my part geometry. So what it's doing is, I'll show you what I mean by that. It's using my drive surface to generate the cut patterns. And then once I have that, I'm actually projecting it onto these this model, this poly surface model. That's why it's machining the poly surface. And I can change the cut pattern if I wanted. I can go in the other direction. So I can go along if I wanted. So that's in the other direction. So you can machine quite complex type of parts with this kind of cut pattern. So you can define your cut pattern using a different surface, but you can machine some pretty complicated features like this. So that's also included in the 4-axis. That's probably our most advanced machining method. So that's pretty much a quick introduction here to the machining methods. You can also do engraving. You can select a curve and project it into 4-axis mode. So if you want to etch some letters or something like that, you can do that as well. So quite
Okay.
a lot of power here. So any questions I can answer at this point?
No, not right offhand. I mean, I need to get a better understanding of a cost evaluation. I mean, we're going to
Okay.
definitely need the 4-axis and the Rhino, the Rhino CAD cam or the Rhino 7. And then, I'll just need to review it a little bit deeper from there.
Okay.
I mean, it appears that you have all the functionalities that we need. But I'd like to understand what an overall cost is and, how many seats you get, how much are additional seats, what is there a maintenance or monthly, just all the ins and outs of the
Okay.
cost analysis.
I'll have somebody from sales give you a call, and you can discuss that with them.
Yeah, and if you don't mind, just have them send me an email. That's a lot easier for me than a phone call.
I see. Okay. All right. I'll let them know. So you want the costs and multiple, how many seats are you looking for?
At least 2.
Okay. So you would also want Rhino as well, right?
That's correct.
Okay. All right. So Rhino plus Rhino Cam. All right. I'll have them send you some sort of some cost information. And
all right, sounds good. And tell me a little bit about the technical support. Is that something that comes along with it, or is that something that is paid for in addition?
we have something called maintenance. When you get maintenance, you get phone support with it. But if you don't get maintenance, with maintenance, you not only get phone support, you will get, we do monthly webinars, by the way, only for AMS people. We do monthly technical webinars. So we show different aspects of our product, our technical guys. I will do one. I have Don, who's also another application engineer. He will do some of those. And those are only available for maintenance customers. And then also with maintenance, you're guaranteed 1 upgrade. So if you buy maintenance, you will get the 2022 product, which is going to be coming out probably early part of next year. So you'll be guaranteed that as well. And then you get phone support. So if you're stuck somewhere and you need a quick phone call from us, we will call you back if you have a support question.
If you will, have them include the maintenance option in there for me as well.
Okay. All right. Sounds good.
All right. Awesome, man. I appreciate you taking the time to go over this with us, and look to hear from you guys soon.
All right. If you have any questions, don't hesitate to drop us an email or call us.
All right. Will do. Thanks so much.
All right, Stephen. Take care. Bye-bye.